Welcome to Bats and Transportation Structures. This video guide is intended to help you understand methods to assess transportation structures for the potential of bat use and occupancy, while providing some basic facts about bats, life history, and their habitat needs. This video guide was developed in collaboration with the U.S. Fish and Wildlife Service, the Federal Highway Administration, and the Georgia Department of Natural Resources in order to aid in the implementation of the Indiana bat and northern long-eared bat ESA Section 7 Consultation and Conservation Strategy. However, the methodologies presented in this video are relevant to inspections for any North American bat species that utilizes transportation structures. At the completion of this video, you should be able to determine the appropriate means and necessary tools to thoroughly inspect a transportation structure for bat use or occupancy. Confidently evaluate and identify features of a bridge or culvert that could provide roost habitat for bats. Confidently identify the signs of bat use or occupancy on a bridge or culvert. And document your findings. In addition, you'll have a better understanding of bat biology and life history. This video guide is not intended to aid in the identification of bat species, nor instruct how to properly handle bats. If federally listed bats are encountered, a specific permit is required to allow for the handling of these bats. Obtaining the proper permit is coordinated through the U.S. Fish and Wildlife Service in a separate process. For non-federally listed bat species, coordinate with your local state wildlife agency to inquire whether permits may be required. This video guide consists of 4 sections. Section 1 will provide natural history information and bat biology. Section 2 will describe what makes a transportation structure a good bat roost. Section 3 will explain how to properly assess transportation structures for bat use and occupancy. And Section 4 will answer frequently asked questions. Section 1. Natural History and Biology of Bats. Bats go about their lives under the radar of most people and animals. They're primarily active at night, spending the dark hours foraging for night-flying insects, navigating and feeding by sound. Even though a bat's echolocation calls are as loud as a dog barking, the sounds are too high-pitched for humans to hear. Bats are mammals and unique in the Mammalia class in that they are capable of flight. Most bats of North America share similar life history traits. They have low productivity, typically having only 1 to 2 young per year. They have a long lifespan of usually 12+ years. And most North American bat species are insect eaters, with a few species in the Southwest and South Florida that eat fruit and/or cacti. Most hibernate during the winter months in colder climates when food resources are lower. Yet some bat species do not hibernate at all. The typical life cycle of a North American bat begins with breeding in the fall before hibernation. Fertilization is delayed until the spring, when females emerge from hibernation newly pregnant. Late spring through the summer is generally thought of as summer maternity season, as pregnant females gather in groups or maternity colonies that may range in size from a handful of female bats to hundreds of thousands. Female bats give birth, rear their pups, and remain in this colonial setting until their pups can fly and feed on their own. In North America, insect-eating bats can loosely be characterized as cave roosting bats or tree roosting bats. Bat roosts are areas where bats sleep, rest, and hibernate. As such, bats need different roosting conditions at different times of the year. This typically varies by species, gender, and roost availability. For example, the Indiana bat, northern long-eared bat, and tricolored bat typically hibernate in caves or cave-like structures and form maternity roosts in trees. And while the Virginia big-eared bat and gray bat also hibernate in caves or cave-like structures, they form maternity roosts in caves or cave-like structures as well. Eastern small-footed bats hibernate mostly in caves as well, but are also known to hibernate in rock shelters and fissures and cliffs, as well as old mines and quarries. Some species of bats roost solitarily during the summer months, while other species, females, form maternity colonies, and males form bachelor colonies. Non-reproductive females often roost individually. The top photo is a southeastern Myodist maternity colony on the underside of a concrete bridge. The below photos are big brown bats on the left and a lactating female and pup, species unknown, on the right. Bats of North America often switch between habitat types, using both natural and artificial roosts. Natural roosting habitat includes hollow trees, caves, rock crevices and sunny rock piles, outcroppings, cliffs, and tailless slopes. The picture on the left is a tree with bark that's sloughing off, which creates nice narrow sheets for bats to shelter beneath. This tree is an Indiana bat maternity roost tree at Great Swamp National Wildlife Refuge. Sparse canopy cover provides sunlight for keeping a maternity colony warm in the spring and early summer, and a clear flight path to and from the roosting area. Eventually the bark flakes off or the tree falls over, and the bats then switch roosts. Switching roosts also helps bats evade parasites and predators that may be drawn to their smells if they stay in one place for too long. As the availability and abundance of natural roosting habitat declines, artificial roosts become an invaluable substitute to natural roosting habitat. Artificial roosting habitat often includes buildings, parking structures, stadiums, mines, tunnels, bridges, and culverts. Artificial roost structures provided to accommodate bats make for good roosts in that they are warm and tend to have consistent temperatures. Bat boxes suspended under a bridge or freestanding boxes near suitable habitat provide safety from predators and, unlike dead trees, remain standing much longer than most tree roosts. In the winter months, many bats in colder climates switch roosts and prepare for hibernation below ground, in caves, and in abandoned mines. Sometimes bats will hibernate in railroad tunnels or underneath the leaves on the forest floor. In warmer climates, some bats remain on the landscape during the winter months and seek shelter during cold periods, with only temporary bouts of hibernation known as torpor. These bats then become active again during short, warmer periods. During hibernation, a bat's metabolism slows down to conserve energy. Thus, bats are highly vulnerable to disturbances during the winter. Each time something arouses them from hibernation or torpor, it can cost them a couple weeks' worth of stored energy. For this reason, many critical bat hibernacula are now gated if possible, or at least have moratoriums against entering and exploring caves during the winter months. Section 2. What makes transportation structures good bat roosts? Of the 47 bat species that live in the U.S., 41 have been documented or are suspected to use transportation infrastructure for roosting. This is 87% of all U.S. bat species that may use transportation structures for some roost needs. Transportation structures make good bat roosts because they contain cracks and crevices that mimic the physical and thermal characteristics of natural cavities. Transportation structures can provide a stable microclimate, predator protection, and proximity to elemental resources such as access to drinking water and foraging habitat. The thermal stability of many transportation structures likely factors into reproductive females selecting them for maternity roosts. Bridges function as permanent artificial roosts. For example, the Monksville Reservoir Bridge in New Jersey, pictured here, serves as a little brown bat roost of more than 100 bats, including pups. Roost locations within bridges may include expansion joints, I-beams, guide rails, weep holes or plugged drains, rough surfaces, and cracks and crevices. In addition to bridge structures, bats have been documented roosting in culverts. Use of culverts as bat roosts is thought to be less common in northern states, but bat occupancy rates were documented as high as 53 to 100% at sampled suitable culverts in some southern states. Roost locations within culverts might include walls, ceilings, and rough surfaces, weep holes, structural fissures, expansion joints, drainage pipes, remnant construction debris, bird nests, and transition points between culvert sections. For example, where a concrete culvert transitions to a metal culvert, or where a box culvert transitions between two poured sections to a circular culvert. Section 3. Assessing transportation structures for bats. Now that you've been introduced to bat biology and the breadth of structures that could be considered suitable for bat use or occupancy, it's time to think about conducting a bridge and/or culvert assessment. Because many bridges and culverts are suitable for bat roosting, and the majority of U.S. species have been documented using these structures, consideration of bat occupancy is an important measure in avoiding unwanted harassment or harm. Many operational activities can inadvertently destroy roosts or cause direct disturbance to bats. Bats are often susceptible to disturbance from activities such as cleaning, painting, repaving, and joint repair and replacement. If you are in an area where bats are known to hibernate in the winter, looking for signs of bat occupancy and use of transportation structures is best done in the active months. In warmer areas, bat use of culverts may be best assessed during winter months. To determine the best survey periods for bat species in your area, contact your local state wildlife agency and/or local U.S. Fish and Wildlife Office. Assessment of a structure begins with a pre-field test survey. Before conducting a bridge or structure assessment, it's important to plan your site visit ahead of time. Google Maps Street View is a great tool for determining accessibility, helping identify a safe place to park your vehicle, and also identifying any potential hazards at the site. Pre-planning your visit may also determine whether you need traffic control to safely survey a bridge site. Safety comes first. Check with your agency to see if there are any occupational safety and health trainings you must have prior to conducting a bridge or culvert assessment. Surveyors should be trained in safe working practices, including tackling steep ground, climbing on ladders, and water safety. It's very important that a high visibility vest is worn during the assessment, as road traffic may be high and pose a significant hazard. Transportation structures may traverse or parallel water courses, roads, or railway lines, which increase hazard potential. Sometimes areas under bridges are not designed to be easily accessible. In fact, there are often fences or other structures meant to deter human access. In addition to recognizing the potential physical hazards related to a site you're inspecting, it's important to take precautionary measures to avoid direct contact with bats and bat guano. Rabies and histoplasmosis are two zoonoses to be aware of. Neither are common, and both can be avoided with appropriate protective measures. Do not touch bats unless you have the appropriate vaccinations, handling experience, and a permit to handle bats directly. If you accidentally come in contact with a bat, it's best to seek medical advice early to avoid potential illnesses. Bird and bat guano are reservoirs for a fungus that can cause a respiratory tract infection. When working in enclosed spaces with the presence of bat guano, it's important to wear personal protective equipment so that the assessment can be done safely. Inspecting a bridge and/or culvert requires specific field equipment. At a minimum, the equipment listed here should be brought to a transportation structure assessment. First and foremost, a safety vest and other appropriate PPE should be worn. A spotlight or very bright flashlight is crucial for looking into very tight cracks and crevices. And binoculars are also usually needed to see areas that are too high to be adequately inspected from the ground level with the naked eye. A camera is important to document the areas of the structure that were surveyed and to take pictures of any bats for species verification. Mirrors can be helpful to see into areas that are hard to view directly with the spotlight. Additional equipment that may be useful, especially for large structures that are difficult to survey entirely, are ladders and other construction equipment such as cherry pickers and snoopers. Bat detectors can be helpful for hearing bats echolocate when they might not be making noises audible to humans. A copy of your state and federal agency's decontamination protocols and any materials necessary for decontamination may be needed. This list is not exhaustive, and new methods and ideas for sampling are always good to try out and share with others. Data sheets are important for recording bat occupancy or bat use of bridges, culverts, and other transportation structures. This form was developed to aid in the implementation of the programmatic biological opinion for transportation projects in the range of the Indiana bat and the northern long-eared bat. The next series of video clips will walk you through a thorough field inspection of 4 common transportation structures where bats roost, the features of each structure that provide habitat for bats, and the key indicators of bat use and occupancy in each of the structures. Structure assessment number 1 is a concrete box culvert over 1,000 feet long. This culvert carries a stream under 8 lanes of interstate as well as on and off ramps. The culvert begins as a single concrete box culvert, but transitions to a Y-shaped culvert midway through, with one side continuing as a single box and the other continuing as a concrete pipe culvert.
Instructors for this part of the training include Lacey Padavina with U.S. Fish and Wildlife Service, formerly Georgia Department of Natural Resources, and Trina Morris with the Georgia Department of Natural Resources.
So this is a culvert that we know at some time of the year has bats using it, but not always. But even when there are bats here, there aren't necessarily really large numbers. So we have to kind of think about what we would be looking for to determine whether or not there are bats here. So does anybody have any ideas of what we might be looking for to determine if bats are using a culvert like this? Poop, right. So if we had bats flying in and out of this culvert, even if we didn't have really large numbers that we could see right away or hear right away, we might see poop, right? So we would look along the concrete areas that are on the sides, even above where the bats might fly out, and there might be guano. What other signs might you have here if you had bats in large numbers that you would immediately be clued into? Smell. Yeah. So this culvert has some airflow. We can feel the nice cool airflow coming out as we stand here. So if there were a lot of bats in here, we might smell them. We also might hear them, right? Right. In this case, though, we've never had very large numbers of bats here. So what we have to do is we have to walk through and we have to look for them. So what are the types of spaces that we might be looking at?
Nooks and crannies.
Nooks and crannies, okay. So any crack or crevice could have a bat in it. Sometimes in culverts we'll also see what's called a weep hole, which is like a plugged drain in the ceiling. So bats can sometimes use those areas.
Shown here is a picture of bats using a weep hole.
There's also sometimes patches along the walls of the culvert where there's been, sometimes use those areas. There's also sometimes patches along the walls of the culvert where there's been damage or small cracks that they have to repair quickly before they do a full replacement. So there could be pieces of wood or blocks of concrete, so we'll look behind those. So this culvert is actually really unique in the way that it changes throughout. So there's a lot of different paths as you go in, which is fairly common in really large culverts like this one, where there's different splits within the culvert and you have to make sure that you check all of those different areas. So why do you guys think that a culvert like this might be, what about a culvert might be ideal for a bat?
Dark.
Yeah, so culverts are really dark, cool temperatures. The temperatures in culverts tend to be really stable, which is sort of cave-like. And in the southeast, like in Georgia where we are now, Culverts are actually more commonly used by our bats in the wintertime than in the summertime because they stay really cool and cave-like with stable temperature. And especially in parts of the state where we don't have a lot of caves, we tend to find bats in culverts a lot.
At sampled suitable culverts in southern states, bat occupancy rates were 53 to 100%, and bat use of culverts as roosts or hibernacula is thought to be less common in northern states, but it is still important to look. Instructor speaking is Roy Hewitt, a student with the U.S. Fish and Wildlife Service.
And so as we walk through the culvert, are you seeing any features that you might expect to find bats?
Along here, any of these rough surfaces could have bats hanging onto them. Bats can really grab onto almost any rough surface with their toes. These small spaces here could at times have bats in them, and as we go further into the culvert, we'll see more cracks in the ceiling and something called a weep hole, where we tend to see bats as well. We do see pieces of wood that are often nailed or tacked up in our culverts, and although there's no bats roosting on or behind this piece of wood, we have seen in other areas where bats will tuck themselves behind these sorts of features that are in culverts. So that is something that we do pay attention to when we're inspecting these structures.
Another thing that might be important to point out is that we would normally be walking through this culvert much more slowly to do a thorough inspection. We would look at every crack and crevice, and in some cases we might have to turn around and look at the areas where these bats might be using. But because we're just showing the class where we know the bats are in this culvert, and it's a very big culvert, we're just kind of moving through quickly.
Yeah, for example, we've even had bats in some places roosting in things like as small as this crevice. So an inspection of this culvert to be thorough would take quite a bit of time under normal circumstances.
They can hang on to any imperfection on the concrete, so just anywhere they can get their toes in. So they may just be free hanging on the culvert, especially if they're not in hibernation. So we could just see them as we're walking through. So generally, when doing an inspection, you try to be very quiet and walk slowly and look at every feature as you're going by.
So as we move into this section of the culvert, we start to see more cracks, and this is a really typical area that you might see bats. This is a weep hole. We often in the wintertime will find bats using holes like that.
Temperature is going to be more stable up in there, right? So this is where we're finding more of the bats that are hibernating, spending time in. And if you look into a crack or crevice and it's covered in spider webs, it's probably a sign that there's not bats using it, or not currently, because the bats coming in and out are going to disturb those spider webs. So that's kind of a way to tell. And you want to also continue to smell to see if you notice any smell, and look for guano when you're looking. There may not be a bat there, but there could be guano, evidence that there has been a bat using it. And it's harder with a structure like this where the guano is going to get washed away by the water, so you won't see it laying there, but you'll see later on bridges that we'll be able to tell, even if there's not bats, that they've been there recently. So if you look, you kind of have to be really careful and look around. You'll see there's stuff right here that is blocking the crack, but it can get in and get behind there. So you want to look really carefully, and your height helps. You can kind of look down there. And so we'll look thoroughly through the whole crack and see if we see anything. And then, like Lacey said, you need to make sure you're turning around and looking behind you, because there may be things that you can't see in one direction. So this is the spot where the structure is kind of, deteriorating a bit, so it's making more of an area for bats. Mm-hmm. And there is a little spider web there, but that area is open, so potentially they could be using it at some point. But I don't see any guano, though we have seen bats in these spots before. They haven't been using it recently.
At a previous site visit, big brown bats were found inside a weep hole.
So we just came through that really long culvert. You were doing a thorough inspection of a culvert like this. You would look in every crack, every crevice. It would take a good bit of time.
So if it were my job to thoroughly check this culvert, I would either need a ladder to go into that upper culvert, right? Or I'd need to find the other end of that upper culvert to check that?
If you looked up there and thought it looked like it could be suitable, but if it's just a shaft going up to the top, then you can probably just look up there and see that there's no bats using it. It's also likely to be really variable in temperature, so because it's open at the top. But if you can clearly see that there's like another culvert on top of your culvert and you can't get to it, you would want to try to check it.
We wouldn't expect you typically to bring a ladder into a culvert. That's complicated and it's not very safe to put a ladder in a wet culvert. We would have at a minimum looked with really bright lights really thoroughly, the best that we could, get the tallest folks on our team to look up as high as they could, and if there's an area like that that you cannot thoroughly inspect because of safety or because of just general inaccessibility, we have a place on our data form to note that as well.
Structure assessment number 2 is a concrete cast-in-place bridge that has heavy traffic flow from an interstate thruway north of Atlanta. The bridge is very wide, as the north and southbound lanes are separated only by an expansion joint. Beneath this bridge is a 2-lane state highway with much lower traffic volumes.
When you're doing bridge and culvert inspections, you're going to be along roadways and traffic is definitely a concern. We always recommend that at a bare minimum you have a safety vest on, and then any other safety precautions that you take are based on your comfort level and whatever your agency requires you to do for safety. Making sure that you're paying attention to cars is really important, and at this site in particular you will find yourself all of a sudden standing in the road because sides are really steep and there's bats right over the road and it's exciting, and so you just have to be really careful and make sure that you are really paying attention and that you're bright so they can see you even if you don't see them.
This bat that we pulled off the bridge, just to give you an up-close look at a bat, this is a Brazilian free-tailed bat. It's a species that's only found in the southern U.S. and it's very easy for us to identify. You can see that tail that's free from the tail membrane is very distinctive, and also it just looks completely different than our other species of bats, so this one is really easy to identify. Now, not necessarily when it's up, 20, 30 feet above you, you may not be able to tell, but in this bridge we have 2 species, and we'll show you how you can look and see that there are clearly 2 different species even if you can't identify those species. So also you can hear this guy is making a lot of noise. We can't hear all of the bats' sounds because their echolocation calls are too high for us to hear, but they do make noises that you can hear, and at this bridge it will be very obvious that there are bats at the bridge.
Wow, look at all those bats.
A lot of them in there.
Oh.
So in this case, you can maybe see that the big brown bats look a little more brown, like those are the brown ones that look a little more like a big brown, and then these grayer looking ones here are Brazilian freetail bats, and so without a pair of binoculars, you'd probably have no clue what species you were looking at, and even with binoculars, you still may not be sure, but you can tell that there's 2 distinct
very
types.
distinctively different. That's cool.
Yep.
So we're at a site now that has actually quite a few bats. And we're seeing bat sign for the first time. So I see lots of guano piling up, especially on the underside of the bridge and some of the supports for the bridge. You can see guano. And really what's different at this location, in addition to the visual sign that we're seeing, is the smell. It really smells like, I don't know how to describe it other than to say funk. It doesn't smell like other animal droppings. Definitely like funk though.
So this is a really extreme example of bat sign, but we want to give a really extreme example so you know a starting point of what you might see. So in this bridge, we're standing underneath an interstate, and there is a northbound lane and a southbound lane, and between those 2 lanes is a longitudinal expansion joint, and the majority of the bats at this bridge are living in that expansion joint. And so that's this expansion joint that's running above us here, and it's parallel to the flow of traffic above, but it's perpendicular to the traffic below. Because of that, there's cars constantly driving through, and the sign that would be falling in the middle of this road is being moved away by vehicles. But you can still tell that there's bats here because there's huge pilings on the side, and you have to use caution when you climb up these because they can be really slick, but there's these big piles of guano. Some of this is just normal debris, but directly underneath the longitudinal joint, there's huge piles of guano. Just below the longitudinal joint, above the concrete caps, there's pilings
that are dripping down the concrete caps, so you can see that guano as well. It's pretty loud under here because there is a lot of traffic, but if you listen, you can also hear the bats making quite a bit of sound. And if you're standing under here, you can also smell them.
Evidence of bat use can include the presence of bats, guano, staining, sound, and/or smell.
Because there's so many. So you have lots of different signs pointing to the fact that there are bats using this bridge in pretty large numbers. So Trina's holding 2 different pieces of guano that's coming from 2 different species that are here. We can't look at a piece of guano and tell what species it came from, but we can look at these 2 pieces and tell that the bats that are here are very different in size. Another tool that we have in the toolbox for guano is that you can send guano off for genetic sampling. Because we know what species are known to be here, we're not going to send this off, but it's just something to kind of demonstrate that if you look around, you can find clues that aren't as obvious, like in this example.
The smaller guano is from Brazilian free-tailed bats. The larger guano is from big brown bats.
Look in this big pile of guano, you can see that this pile has been accumulating for quite a long time, and if you look close, you can tell that there is fresher guano, which is the wetter looking guano that's piled on top of the drier, older guano. So not only are bats here now, but bats have been here before, and based on the size of the pile, they've been here for quite a while.
Structure assessment number 3 is a pair of concrete, pre-stressed girder bridges carrying a divided 4-lane state highway over a large perennial stream. The bridge is over 100 feet above the stream bed and cannot be completely inspected without the assistance of construction equipment or emergence count.
At this bridge, something that's cool to note is that the area that the bats are roosting is completely different than what we saw before. It's pretty common to see bats roosting in expansion joints, which are present on most bridges, but we've mentioned throughout the day that bats can also grab onto any kind of rough surface, and they can just be on the sides of the bridge. And the signs of bats at this bridge over here are just on the concrete. This bridge is also pretty different because it's really, really tall and it's over really high water. So at this site, we want to take the opportunity to talk about some other tools in the toolbox that you can use to do inspections when you can't necessarily do a thorough inspection just with a spotlight and a set of binoculars like we could earlier today. One of the things that you can do if you have a bridge that's really tall like this one is you can see if there is construction equipment available. So sometimes if it's a project, especially a project that's coming up for construction or maintenance, and they really want to make sure that there is a thorough inspection, the transportation department can assist by bringing things like cherry pickers and other types of construction equipment to actually put you right under the bridge in the center where you need to be, which is always fun and interesting and a little bit different than the inspections that we do from the ground. Another tool that you can use that wouldn't work here but works at many bridges is to just use a ladder. Sometimes you're not allowed to do those things based on whatever the safety regulations are where you're working, and you don't have to. There are things you can do from the ground. So one of the things that you can use is you can use a bat detector to see if you can hear anything. This is a bat detector. There's a lot of different types. They don't all look just like this, but the principle behind a bat detector is to pick up the echolocation calls that bats make. So you've been to a site where you can hear bats that are making audible noises, but they also make a lot of noises that you can't hear audibly. And I'll demonstrate. We don't have a bat here, but you can hear that my fingers are making a noise even when my fingers aren't making a noise. So getting species identification with a bat detector at a bridge is not the greatest ID method, but it can help you determine whether or not bats are there. I mentioned here that we have an obvious sign that bats have been here, but the bats aren't here right now. So you can use genetics to figure out what species you have, especially if you're in an area where there could be or federally listed species and you want to make sure you know what species are using an area. We in our state have created these little kits that we give everybody who's regularly working on bridges. We have test tubes, we have gloves, and data forms, and so if at any time an inspection is being done on a project where there is sign but no bats currently present, the guano can be sent off for DNA so we can help try to figure out, using that method, what species we have.
We get a lot of questions about staining, like how do we know that dark staining isn't bat staining? Well, look closely, and if you have binoculars, you can really look up at that area and know that, do you see the difference between this site and the last site we were at, where you could see piles of guano on caps and then there was a space. So here, that concrete goes all the way down to the top of the cap. And if you look with your binoculars, you can see that there's like a little gap, but probably not a big enough gap for bats. And you can also look along there where that staining is, and you can see that there's no guano stuck to it. That's going to tell you that there's probably not really a lot of available habitat. You would want to go down to the bottom and make sure there aren't any piles of guano down there if it hasn't been flooded recently. And you can say, all right, this is probably, we don't need to bring in heavy equipment to look at this because there's not really any signs of bats. I'm not hearing anything, I'm not smelling anything. So you can't be 100% certain there's no bats over there, but all of the signs point to not available habitat and no bats. We see so many different bridge designs. You really need to think about whether there's actually space for a bat to be there and whether there's any evidence. We get a lot of questions about how can I know that I'm not missing anything? And we're trying to give you all the tools to look for stuff, to look for the sign and rule it out. Like, I don't see any obvious sign. That doesn't mean you'll never miss a bat. What we're trying to make sure is that you don't miss a significant number of bats or a site that could have a significant impact. That's the best we can do. We do occasionally have bats that get into bird nests, and we have areas of bridges that are hard to look into. This is pretty low tech. It's just a little mirror that's on a telescoping pole. It's not good enough for me to look up here, but a taller person could potentially, and you can see that I could look up here to see if there was any guano if I was looking for it, or if this were an area that maybe have a crack or crevice behind it that I wanted to see into, I could look at this mirror. Useful. You can use your spotlight to sort of shine up and help you to look in there.
You can just imagine it like lots of greasy little bat bodies all next to each other, and they just drop droppings all over the side of this, and there is really no other animal that would roost here and do that. And you can see there's lots of little rough places that they can grab onto with their little toes, and then they're dropping all this guano here. So even if this pile weren't available as a sign for us, say there was a huge flood or we were closer to the water and this washed away, you should still be able to see all of this and know that you've got something going on with bats.
Number 4 is a pair of concrete pre-stressed girder bridges that carry a 4-lane divided highway over a low-volume 2-lane county road. This bridge is very unique because the vertical sides are composed of retaining walls with spaces and crevices for bats to enter. It is unknown exactly how much of the area behind the walls is accessible to bats. A thorough inspection of this site is challenging and may require an emergence count with multiple viewpoints to see all of the areas being utilized by bats.
A boroscope, optical device with a camera and display, is used here, along with a cell phone, to look for presence of bats in hard-to-reach areas.
We are doing a bridge inspection. It's very important to also check above the bridge, not just below, which is where we've been looking until now for bats. And one of the places you can look is in the cracks and crevices above. Sometimes they're traveling from the bottom to the top of the bridge in these areas. So we go across the bridge and shine our lights in every joint and crevice and look to see if there's bats or evidence of bats. Another thing that's important to look at for all of you guys is if you are seeing staining or debris below the bridge and you don't see any guano and you can't tell if it's bats, one thing you can look at when you're above is whether or not there's holes in these joints. So this bridge has been recently resurfaced, so you can see that this joint it's mostly covered, but if you walk along the edge, like right here, you can see it's already starting to come apart, and there will be places where there will be debris and water running down under the bridge, and so that can be a way to determine if you can't really get to it, you're not sure if you see guano, look above and it's like, oh yeah, there's a big hole here. Clearly there's been a lot of water coming through, so that's one way to kind of do some detective work to see if it's bats or not. But if you want to look over here in these joints, this is a place where we commonly see bats. And if you look down, does anybody know what these are? Anybody have a guess? Yeah, they're bats.
brown bat. They don't look like the free-tailed right? You can see faces there, so, and there are likely adults and pups. That little guy down there looks kind of like he's a little younger and smaller, a little more fresh looking. Or he might be a juvenile. There's probably females and they're young in here, and at this point, these young are either flying or getting ready to fly, and you can't really tell the difference between them and the adults unless you have them in hand and can look at their wing. This bridge definitely serves as a maternity colony at some points during the year. And this is typical that they move around a lot, so they might be in one place one time, and then the next time we come, they'll be on the opposite side of the bridge, and that's likely because they're using different areas during different temperatures. It's a good way to think about, like, this is a crack or crevice that you would maybe find on a rock face in the middle of the forest that gets some sun exposure. So this is really mimicking natural habitat, and it doesn't look like a great spot to raise your young because it's going to rain in here, but if you think about it, it's got to be just the right kind of rain to really soak them. And if you look at this bridge, they can move under this barrier and get out of the rain really easily. So this bridge has bats on it all the time. We don't know exactly where they are. We see their poop, we see their staining, we see them sometimes. So it's much trickier than the other sites where we've seen obvious large quantities of bats or large piles of guano. We don't have that anywhere here. There's no really obvious entry and exit point where they're using all the time. There's scattered spots all over the place.
All right, we're just wrapping up our bats and bridges training. We learned a lot today. The first thing is, to find a bat, you gotta find the poop. It's all about the poop. The second thing we learned was anything that's a 1/4 to 3/4 of an inch is big enough for a bat to squeeze into. So any crevice or weird surface on the side or under a bridge is perfect habitat for a bat to squeeze into. We learned about road safety. We learned about all sorts of equipment that you can use to help in surveying under bridges. What else?
We went over a lot of the different tools that you can use for an inspection when you can't do one just from the ground with a spotlight and binoculars. So we covered ladders and construction equipment and borescopes and mirrors and genetics and emergence counts and all sorts of things that you can do to make sure that your inspection is thorough.
Excellent.
And we learned about what bats smell like and what bats sound like.
Section 4, Frequently Asked Questions, FAQs. Bats. Bats and transportation structures, questions and answers. Number 1, what do I do to plan my assessment work? If you're in an area where bats are known to hibernate in the winter, looking for signs of bat occupancy and use of transportation structures is best done in the active months. In warmer areas of the country, bat use of culverts may best be assessed during winter months. To determine the best survey periods for bat species in your area, contact your local state wildlife agency and/or local U.S. Fish and Wildlife Office. If you are not able to survey during the active months or signs of bat use and occupancy are noted in the inactive months, coordination with the wildlife agencies can help you plan for possible further assessment in the active season. Question number 2. What do I do if my assessment documents bat occupancy and/or bat use? The first step is to coordinate with the state wildlife agency and local U.S. Fish and Wildlife Office to have a qualified biologist verify bat use and, if possible, identify the species of bats. If bats are present and obtaining photos is possible, it's helpful to provide the wildlife agencies with photos of the bats, photos of the signs of bats, for example, guano and urine staining, and photos of the site. Close-up photos of the bats may be used for species identification. Another tool for species identification is the use of an acoustic monitoring device, a bat detector, to record bat calls and identify specific species. Question number 3. What if a complete assessment cannot occur due to access issues or safety concerns? If a bridge or culvert assessment cannot be completely surveyed due to access issues or safety concerns, alternative survey methods may be necessary. In these situations, it's best to consult with the appropriate wildlife agencies as early as possible in order to identify the needs and requirements. Typically, construction equipment may be used to address challenging access issues, and emergence surveys or passive acoustic surveys can sometimes be used in lieu of bridge culvert assessments to determine bat use and/or occupancy. Question number 4. How can transportation agencies minimize disturbance to bat colonies in highway structures? Early coordination with your local wildlife agency or U.S. Fish and Wildlife Office can help to answer this question for the species in your area. In general, if the structure is occupied during the active season, the best way to avoid negative impact to bats is to conduct construction activities outside of the full maternity pup breeding season, typically April to September. If the entire active season cannot be avoided, work conducted outside the non-volant, non-flying pup season, typically May to July, is another minimization strategy. If work cannot be conducted outside the active or non-volant pup season, or if the structure is occupied by bats in the winter, minimization measures can be collaboratively crafted by the wildlife agencies and the DOT on a project-by-project basis. Possible minimization measures include working only at night, excluding bats from the site structure by traditional means or acoustic deterrence, or having agency personnel on site for hand removal. Question number 5. How do I proceed with a project that will cause disturbance to bats on a bridge or culvert? The answer to this is always, it depends. Early detection and subsequent coordination with the State Wildlife Agency and/or the U.S. Fish and Wildlife Service can help you answer this question in more detail, but typically there is a path forward for conducting the work. If the species is not protected under the Endangered Species Act, you will still need to coordinate with your state wildlife agency, as state-level protections for bats may vary. If the species of bat using a particular structure is federally listed, coordination and consultation with the U.S. Fish and Wildlife Service should be initiated early. Minimization measures may allow a project to proceed without further consultation, but if take of the listed species is unavoidable, formal consultation may be necessary. Question number 6. Does bat presence affect the integrity of a transportation structure? There is no scientific data that shows bat occupancy and/or use of a transportation structure threatens the integrity of the structure itself. According to the Bats in American Bridges publication by Keeley and Tuttle, 1999, Bridge Assessments in Texas, Question 7. What conservation measures are available for avoiding, minimizing, and compensating unavoidable impacts to bats? In addition to expertise from your local wildlife agencies, there are multiple resources available that include best management practices for avoiding, minimizing, and compensating for impacts to bats from transportation activities. 2 key resources include, number 1, the June 2019 National Cooperative Highway Research Program report, titled Bridging the Gap Between Bats and Transportation Projects. This report includes a chapter that details mitigation practices related to habitat preservation, habitat enhancement, and habitat creation restoration. And number 2, the California Department of Transportation's technical report that details the most effective mitigation strategies for maintenance and construction activities that impact bat populations and their habitats. These resources and others are found at the U.S. Fish and Wildlife Service's Conservation and Consultation Strategy webpage for the Indiana bat and the northern long-eared bat. https://www.fws.gov/midwest/endangered/section 7/FHWA/index.html. Question 8. What if I miss something during a bridge or culvert assessment? Many assessors worry they may not observe bats or signs of bat use that are present on a bridge or in a culvert. Many structures are only used temporarily by a small number of bats. Therefore, as with any species survey technique, there is a possibility individual bats or signs of bat use may not be detected. However, if a bridge or culvert is used as a roosting location by a large number of bats, especially a maternity roost, this training provides the tools you need to successfully identify such a significant roost. How do we define significant? In general, if there is a large enough number of bats, or a few bats are there long enough to increase the likelihood they will overlap with and be impacted by construction activities, there should be signs of their presence that will be easily identifiable to those that have taken this training. If individual bats or signs of bat use are not observed during the assessment, but are later observed during construction activities, contact your state wildlife agency and/or local U.S. Fish and Wildlife Office. You have now completed the Bats and Transportation Structures video guide. For additional information on assessing transportation structures for potential bat use and occupancy, or to locate the appropriate contact in your state wildlife agency and/or local U.S. Fish and Wildlife Service office, please refer to the Points of Contact web link available on the References and Additional Resources webpage listed in Q&A number 7.
Disclaimer: video was filmed prior to COVID-19 restrictions.